Hello, today we're going to talk about centripetal velocity, which is based on period and frequency, or it can be based on period and frequency. But as we said last time I made a video, we kind of talked about how often something can go around in circles. And what centripetal velocity is it's the speed with which something goes around in circles, specifically the linear velocity if this thing were to come out of going in circles. We know that if something is going around in circles and the force that's making it go in circles stops, it would go off in a tangential manner. So the equation is pretty simple. It's a very simple velocity equation, which we know velocity is distance over time. But if we remember when we're talking about centripetal velocity, it's not really a distance, because a distance is pretty arbitrary from point A to point B, wherever it is. When you talk about something going around in circles, I guess the best way to think about the distance would be the distance from the start of the circle till the start of the circle again, because a circle is just an infinite loop. So when we talk about centripetal velocity, you're really talking about the distance of one loop, one time around, one circumference, I guess, one circumference, over the time it takes to go around that circle once, which we now know is capital T, or the period. And last time I checked, the circumference is 2 pi r over capital T, the period. So, and you know, we need to remember that the radius is always in terms of meters, and the period is always in seconds. And if we give you something in a frequency, or if we give you cycles in seconds, you're going to need to do some conversions to get things into the period. So why don't we actually try a little exercise here, where I give you some information and we can try and figure out the centripetal velocity. So we need to know a couple of pieces of information. You need to know the radius and you need to know the period. So let's say I've got an object that goes around in circles, and let's say it makes a loop once every, let's say it's an airplane. So let's draw us a little airplane. Airplane. And let's say that airplane goes around in a nice, I'm not going to say a loop, because that's going to get things out. That would be okay, but let's just say it goes around a nice horizontal loop, not a vertical loop, but a horizontal loop. And let's say that airplane takes about 50 seconds to get around that loop. And let's say that loop it's a big loop. Let's call it a 400 meter loop. So that's kind of all we need to know. Let's say it's a 400 meter loop from start to finish, and that would make our radius half of 400 meters, which would make the radius 200 meters. So now I guess all we have to do is really plug and chug, and the equation is VC equals 2 pi r over the period, which is going to be 2 times, we can say 3.14 times the radius, which is 200, all over 50 seconds. And if I can get my calculator up and running, it's a pretty easy calculation to do. 2 times 3.14 times 200 divided by 50. And that would make that plane, it'd actually be going very slow. That would make the plane be traveling at a velocity of 25.12 meters per second. About 50 miles an hour, so we'd never want to see an airplane going that slow. But that's what the calculation would say. A little tougher. Now let's say I give you some different units. Let's say that same plane, and we'll change the speed, but let's say that same plane is going to go in a big circle, and let's say that circle has, this time let's say the radius is 400 meters. And let's say that the plane goes around this circle, I don't know, 5 times in 2 minutes. So now this is an issue because this is not going to give us a period. We have cycles, which is the 5 times the 5 loops, the 5 circles, and this is minutes, so we've got time. And we know that frequency is cycles per second, so we have to somehow get that minutes into seconds, and we have to get those cycles into cycles. So we're going to have to do a little bit of dimensional analysis. We're going to have to get a little creative. And we can say the frequency of this is going to be 5 cycles over 2 minutes, but last time I checked, 2 minutes, we need this to be in seconds. So 2 minutes times 60 seconds per minute. The minutes are going to cancel, and we're going to end up with 120 seconds. So 5 over 120, that's going to be a very, 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 very small frequency. 5 over 120. That's going to give us a frequency of 0.041 hertz. And I guess this is the big deal when I say, well, we don't usually talk about frequency when things are bigger than a second, because you get a very small number, just like we don't talk about periods that are smaller than a second. So what we would do here is we would say, well, that's nice, 0.041 hertz, but we need to get that into seconds so we can have a period. And the way we do that is period is 1 over the frequency, which is going to be 1 over 0.041. And now we could say 1 divided by 0.041, 24.3 seconds. So now I know my period is 24.3 seconds. So now I can go and say, all right, I have a radius and I have a t, because this is the time it takes to go around one cycle. And now I can figure out my centripetal velocity as 2 pi r over t. dc equals 2 pi times the radius, which is 400, over 24.3 seconds. And let's see here, that's going to be meters. And 2 times 3.14 times 400 equals, now divide that whole thing by 24.3, 103 meters per second. That seems more in the ballpark. 100. Let's go. Equals 103.3 meters per second for my centripetal velocity. So I hope that helps. Anytime you're asked for a centripetal velocity, anytime you're asked for the speed, that's kind of how you do it. All you need is one equation, and the big thing is you have to remember that whatever unit of time you're given, you have to get it into seconds. And even if it means you have to go from a frequency to seconds, you have to do that. And just remember that they're reciprocals of each other. So I hope that helped, and we'll see you in the next video.